Nice. Today topic is ADC interfacing with 8086 using 8255. Let us see what is the importance of ADC conversion, that is DAC conversion, in a real-time application. We are observing that digital communication is plays very important role in a modern race. That is that we required the ADC and also DAC. So what is the ADC? Analog to digital conversion. Nothing but the analog signal what we are transmitting that will be converted to digital. In a digital form, the signal will be transmitted. The advantage here, over a long distances, even though the digital signal is transmitting, it does not lost its energy. So that it is more advantageous to transmit a signals in a digital form rather than analog signal. The end user required analog signal to use for TV remote, mobile data and all. So that we require the second conversion, that is digital to analog conversion. So this is the importance of a digital signal to transmit a long distances. Because of this, the ADC interfacing and DAC interfacing is very required for the latest computer 8086 using 8255. Let us see how the interfacing can be done for a ADC in a 8086 using 8255. We will see one by one, step by step. So this is the ADC. Students, you please remember that the ADC interfacing is done, but the analog to digital conversion is done by only the ADC IC. So this is the ADC IC. This IC will convert the analog input to the digital output as a 8 bits, that is output 0 to output 7. So this is the conversion of a ADC. By using this ADC, the converted signal is interfacing to the 8255 and 8086. How it is? Let us see one by one. See there, we have a 8255. So 8255, how many ports we have? We have 3 ports. Port A, this is the port B, this is the port C. So these all ports are connected in different mode of operation that we will discuss one by one. First one is, see there, the port A is taken input from the output of a converted signal in a digital form. So port A must be act as a input. Now see here, first step, port A is input. Now what is a port B? Port B is provide the output signal to the ABC to select the corresponding analog input. So that is port C's output. Now port C lower, that is 0 bit, is also a output signal. It will provide the SOC signal state. The higher bit, it will take the input from the ADC, that is end of conversion. So it is the input. See there, PCU upper is the input. So according to this port operation, the control word we have to calculate, that is 98H. See here how to calculate the control word for the different mode of operations. So we observe that here the D7 is mode of a entire CWR in a 8255. What is the mode? There is a 2 modes. One is BSR mode, next one is IO mode. So we are operating, this is IO mode. When IO mode is operating, it is a 1 D7. See there. Now mode A has a mode 0 operation. So D6, D5 is initiated as a 0. Now port A, what is a port A? This is our port A. It has an input port. When the input port operation is taken, the D4 will be energized, initiated or triggered to a logic high, logic 1. Similarly, port C upper, that is a again input port. Mode of a port B, mode 0. Next, port B. What is the port B? Output. So output mode, it is D1 is initiated as a 0. Port C lower. What is the port C lower? Port C lower is also output. So when it is output mode, it is 0. When it is input, it is 1. So like this we can take the control word register different mode of operations. Port A as a input port, port C upper input port, mode of a port B is mode 0, so 0, port B is a output mode 0, port C lower also output, so it is a 0. So this is the way of calculating the control word to interfacing port A, port B and port C with the 80 ADC with the latest computer 8086. So here we can connect the 8086 here. You can connect the 8086 latest computer. So this is the entire circuit for ADC interfacing with 8086. So we will go for second step, step number 2. So see there, it is the higher byte is a 9, lower byte is the 8. Is it 8? 2 power 3 is the 8. This is 0, this is 0, this is 0. So 98. So the control word register for the interfacing port A, port B and port C is 98H. This control word is used for the assembly language programming. When you are writing the programming for the ADC interfacing, this is the very important calculation that we can use later. Now step number 2. See there, step number 2, port A is selected as a to store ADC output. So the digital output is obtained through port A. Remember that the digital output is where stored in 8255 port A. Now port B is used to select as a input channel. See that this is the port B. Port B is providing the ABC logic high or logic 0, logic low to select the corresponding input signal. Suppose if I want to select this one as a input to 2, nothing but analog signal is 2. How it is? Let us see one by one. See there, I want to select as a analog signal is 2. So what is it? 2 power 0, 2 power 1. So this is the 0, 1, 0 makes the analog input signal is select as a 2. Like that I can take the analog input as a 5, analog input as a 6, whatever it is. That also you can observe. So the analog input to 2 is provided at the input channel 2 for the conversion to the digital form. So this is the selection of a input by using port B0, B1 and B2. Let us see if you want to select whatever it is. To select the 5, what is that? 101 is the corresponding signal from the port B. So this is the entire selection of a input from the port B. Now let us see step number 4. So what is step number 4? The port C is used for only conversion. This is, see there, starting of a conversion and end of a conversion. The port C is exclusively used for start of conversion first until up to end of conversion. How it is, we will observe one by one. See there, the conversion is done by SAR, that is ADC operation. Again, dear students, you remember that the conversion is done by ADC, not by interfacing A255. A255 will not do any conversion. Only ADC IC will convert the analog input to the digital. A255 is used to interface the computer 8086 and ADC. This is the thing. Now how it is, we will see now. How the method of a conversion, let us see. Suppose I want to given the input 5.1 volts. So the first higher bit is 1. So what is the value now? 2 power 3, 8. So 8 is less than the analog input 5.1 what we selected. So what happened now? Simply the higher logic bit will be shifted to next bit. That is the thing. Let us see how it is. See there, higher bit is shifted to 1. If it is not less than, so if I want to increase, it is 4 volts now. See there, but our input analog input voltage is 5. So what we have to do? We have to increase that. When we are increasing the result, what it could be, we could not be shifted, we have to hold it. See there, I represent it is holding, nothing but the bit number 3 is holded as usual. The next bit will be given to the higher logic. Let us see next one. See there, it is holded and next bit is given the priority of a logic 1. So what it is this? There is 2 power 0, it is 2 power 1, 2, 2 power 2, 4. 4 plus 2, what is that? 6. So what is 6? It is higher than the 5.1. Again we have to decrease the value because it is 6 is more than the 5.1. Now when it is decreasing, what is that? It will shift to the next bit. This one will be shift to the next bit, so that end of conversion is achieved. This is the end of conversion is achieved. Like this, the start of conversion until up to end of conversion is stored in the port C of a 8255, which is interfacing 8086 latest computer. So this is the simple method to understand. Same thing we are going to be used when it is programmed. Our interfacing 8255 is programmed. How it is, we'll see in the next step. See there now. At last, the remaining functions we know that is ADC is enabled by output enabled, address latch enabled, that will latch the address lines. A1, A2 are used for the port selection. This is the A1, A2 are used for port selections. Read write operation by IO or IOW. This is the simple as usual, the remaining interfacing things. Now next one is, let us discuss how the program can be used to interface our 8255 with ADC. We know that the first step is we are using the assume directory to start the assembly language program. See there, so there is a assume directive. That directly you can use to start our ALP, nothing but assembly language programming. So here see that this is the code. The code can be named as our name, not only use code segment. If you want, you can use our own name, username. So the next one, see there, we can start the program now. So at last we can end the entire code. In between start and end, we can write our ALP, assembly language program. How it is, let us start one by one. It is very simple to understand the assembly language program to interface the ADC with 8255. Very simple steps, only 3 steps is required. First one is initializing the control word. What port is acting as a what mode? So port A, port C upper is output, the port B, port C as input. So what is the control word? We initiated the accumulator registered with a control word 98. We push the 98 to the accumulator. So the output of a CWR is enabled to write the control word for the different mode of a port operations what we selected for the ADC interfacing. Now the next step is, see there, we are again making the 02. What is the 02? It is our analog input we selected, that is moved to, that is pushed to the AL accumulator register. So what is the port B? Port B is the output port. So output port will be initialized by our analog input, that is 02, what we are providing in the ADC 800 IC. Now next is, I said now only 3 steps. This is the first step, initialization is over. What port is acting as a input or output, like that. Next one is we have to start the conversion. This is the simple logic to start off a conversion. See there, to start off conversion we have to give the clock pulse 0 1 0. So first we have to provide the 0, next we have to provide the 1, next we have to provide the 0. This is the activating or initiating the clock pulse for the 8255 interfacing. See there, the first one is, first these 2 lines are used for to initiating the, to trigger the clock 0 state. See there, clock 0 state. So accumulator is loaded with already I said that port C is exclusively used for what? Only for conversion, start of conversion to the end of conversion. So the port C is first is loaded with 0 0. Next one is loaded with logic high. See there, logic high. Later it will be loaded with 0 0. So this is the given the clock to start the conversion. Until up to end of conversion, it will be used for the good result, that is what is the output form, digital form, output digital form, until up to that the start of conversion will be repeated. Now this is the third step. You please understand very carefully. It is very simple loop. This loop consists what? Jump no zero, nothing but the port C upper bit. If it is 0, what happened now? This wait loop is goes to the first line, first statement. See there, the port C AL accumulator, it is as a input port, so that is I represented, I initiate as a IN. So we are rotating this with a carry, nothing but here there is no carry, 0. What happened now? Jump no zero. What is jump no zero? If no carry is there in the port C upper, then only this entire loop will be repeated. If the carry is there, what happened now? It will come out from the loop. This is a simple logic. Please understand, dear students, once again, this is a very simple loop. Whenever the carry is there at the port C upper, this loop will be completed, nothing but start of conversion is completed, end of the conversion is reached. See there, carry is 1, end of conversion is reached. Before reaching end of conversion, what happened now? This will be in the loop itself only, like that. This is not EOC, this is SOC. It is a small mistake here. So entire loop, you understand what is the start of conversion loop, how the end of conversion loop is come out from the wait, what we represent named as a loop. So this will complete until up to end of the conversion. Let us see how to convert starting of a conversion to the end of conversion. See the first same example I have taken, what I explained to you. The analog input is 5.2 volts, so the first one is 8 volts not reached. So what happened now? It is logic 0. So the carry is 0 only. Now next step is also what happened now? 4 not reached to 5 volts, so the carry is 0 only. Next one is, see there, 6 volts not equal to our 5 volts. What is the analog input? Again what happened now? The carry is 0, nothing but jump no carry, nothing but the loop will be repeated. How many times? 3 times. Now the fourth time what it is happened? See there, 5 volts. So approximately the analog input voltage is converted to the digital. Now what happened now? This port C upper will be triggered, will be initiated as what? 1. Nothing but the carry is 1, not 0. Then what happened now? The wait loop come out from the simple loop what we written in the assembly language program. Now the control will come out. Now see there how it is now. We'll see. Now it is port C upper is triggered, initiated as a 1. So EOC is achieved, nothing but the end of a conversion is completed. So this is the way of providing the SOC to EOC in the ALP assembly language program. This is the entire program for the ADC interfacing. So the code ends. So this is entire operation of a what is called as ADC interfacing. Thank you all.